This is a presentation of week 2 for of week 2 week 2 this is a presentation of week 2 for construction engineering design of Hanyang University. Yoon-jin presenting. The official name of the building shown in this picture is Taipei World Financial Center, but we are more familiar with the name Taipei 101. It is well known as one of the tallest buildings in the world, and this comes one of the attractions for tourists. The exact height is 508 meters, consisting of 101 floors. Lower part of Taipei 101 is used as a mall, and the upper part is used as an office complex. We will introduce Taipei 101 along this order. Taipei 101 is located at upper end of Taiwan. This place is not in the best condition for the tall buildings since it's windy, and lots of typhoons pass by. Also, earthquakes happen to occur often compared to the inland areas. Taipei Financial Center Corporation was the client, and C.Y. Lee and Partners designed it. Structural engineers and consultants also took place, examining its stability in such a bad condition as explained before. The height to the top floor of the Taipei 101 is 438 meters, and the height to the spire is 508 meters. The floor consists of 101 floors above ground and 5 floors below ground, and has a total floor area of 412,500 square meters. In order to get to know about Taipei 101 deeply, history should be handled. First of all, in 1997, the Taipei Financial Center Corporation, the client, won the rights to lease the site for 7 years and to develop a building. This was the start of the famous Taipei 101. So, the construction began, and it was possible to see the first tower column in 2000. Interesting thing is that the city allowed this building to be 101 stories high after the construction have started. In 2002, when the process was partially done, earthquake of magnitude 6.8 struck Taiwan. Since Taipei 101 was designed to survive strong lateral loads, it was undamaged. Taipei 101 was completed and was opened to public after 1 year. In 2009, Taipei Financial Center Corporation announced plans for green building, and 2 years later, it became the world's tallest green building. Initially, the owner, Taipei Financial Center Corporation, planned lower buildings covering the whole block, but all the investors and occupants wanted room in the tallest building. A single tower was the best to please everyone. The unusual tower shape was drew on local culture, including the regularly shaped joints in tall, slender indigenous bamboo and pagodas by architect C.Y. Lee. The building has 8 modules on the upper body, which has 8 stories each, and the number 8 means luck, and the number 100 symbolizes perfection. 100 plus 1 represents further breakthrough and innovation and a new beginning. A 5-story high open space, Taipei 101 Mall, effectively combined the urban pedestrian street, providing entirely new experience for Taipei citizens. A multifunctional urban social space is provided on the 4th floor to create a cultural and fashion holy land for the city. Super-scaled structural elements enclose an enormous central space, utilizing the different moods created by the light filtering through the skylights at dawn and dusk, and creative interior design elements to exhibit the 5 aesthetics of the new Taipei Life Society: discourse, experience, exhibition, and celebration, providing a unique and multifaceted urban living room for Taipei. Before we go into complicated stuff, we're going to spend some time knowing interesting facts regarding Taipei 101. It is well known with its fast elevators. We can rise from 5th floor to 89th floor only in 37 seconds. The elevator in Taipei 101 set a new record in 2004 as the fastest ascending speeds in the world, which lasted to 2014. Also, it received LEED Platinum certification. It was well developed, especially in leadership in engineering and environmental design for existing buildings, operations and maintenance. There are 4 factors that we can look into. First, saving electricity usage got possible, especially regarding lighting. Second, water consumption was lowered. 28,000 metric tons of water was saved. Also, they worked on the garbage production and made it possible for 1,261 metric tons of garbage to be saved each year. Lastly, indoor air quality was handled through the control of HVAC systems, applying improved algorithms for the chiller plant, and changing the sequence of operation helped a lot. Taipei, with 101 floors, weigh 705,130 tons. Unlike other buildings of ordinary size, such a large building has several considerations in construction. First of all, when constructing skyscrapers, a well-planned foundation is required to anchor them to the ground. For a well-planned foundation, soils have to be strong enough to support the weight of the skyscraper. Topsoil and subsoil are not strong enough to support the skyscraper and must find bedrock deep in the ground. After finding bedrock, vertical beams are sunk through the soil until they are embedded in the bedrock as footings to secure the structure. Also, we have to think about the impact of the water table on the foundation of the building. And the water table exists 2 meters below the ground, creating a huge uplift force. Slurry walls were constructed to prevent the impact of this water table, which is deep wall constructed on site to prevent water and soil caving in while construction of foundation and excavation. These walls surround both the tower and the podium and are 1.2 meters thick and up to 47 meters below ground. And secondly, high-rise buildings are very affected by strong winds and earthquakes, so they need a structure to prepare for this. In particular, Taipei 101 is a dangerous environment that witnessed a 7.1 magnitude earthquake during the construction and Category 5 typhoon in 2015. Thus, Taipei 101 prepared various structures to prepare for wind and earthquake forces, the most famous of which is the tuned mass damper. At the top of the building between the 86th floor and 92nd floors of the Taipei 101 is a huge pendulum called tuned mass damper, or TMD. The pendulum measures 768 tons and is 6 meters in diameter. It is built of stacked steel plates and weighs 0.24% of the total building weight. This damper uses building motion to push and pull giant shock absorbers to convert motion to heat by forcing fluid through small internal openings. When the building sways, the mass will tend to move in the opposite direction. This removed energy from the building due to the wind oscillations and reduced movement. In the event of an earthquake, the sudden shock locks the mass for safety during seismic events. Beside these structures, there are several special structures of Taipei 101, and let's first look at the superstructure of Taipei 101. The building used outrigger and belt trusses to imitate the joints of bamboo. This same structure was repeated 8 times to form the superstructure of Taipei 101. Let's learn more about outrigger and belt trusses, which are not only used to describe the shape of a bamboo, but also to add safety to the structure of the building. Outriggers, or as the name suggests, are extra structural members to resist the overturning forces. In structures, outriggers basically tie 2 structural systems together, which are core and perimeter systems. When subjected to lateral loads, the column-restrained outriggers resist the rotation of the core, causing the lateral deflections and moments in the core to be similar than the system without the outriggers. The external moment is now resisted not by bending of the core alone, but also by the actual tension and compression of the exterior columns connected to the outriggers. Belt truss, as the name suggests, forms a belt around the building, connecting perimeter columns. Belt trusses are often provided to distribute the tensile and compressive forces to a large number of exterior frame columns. In Taipei 101, belt trusses below level 27 are 2 stories deep. For upper floors, the belt trusses are single story deep, every 8 floors tying main perimeter columns by cross-bracing. These belt trusses gather and transfer perimeter weight to 2 spur columns on each face. As we were searching for the general contents, we were able to set the direction of the project. Based on further research of the construction methods and problems faced while construction, we will have better understanding of the construction process. Also, we will study how each construction methods solved the problems faced. This is a study plan we set for further project. We will set more developed and specific research direction next week. After entirely understanding the building, till week 4, we will study construction methods separated into specific components. Thank you for listening to our presentation.